Hey, all you modularists out there, welcome to Celestia Spotlights, where we hear from the people at the forefront of the modular movement. I'm Nick White, COO of Celestia Labs. Today, I'm thrilled to have on Neel Somani. Neel is co-founder of Eclipse, where he's building the first customizable modular rollups using the Solana VM. Yes, you heard that right. The Solana VM is going modular and coming to a rollup near you. Neel is here to tell us all about that and more. Neel, welcome to Celestia Spotlights. It's been a crazy week. How are you doing?
Hey, Nick. Thanks for having me. Yeah, it has been a crazy week, especially for the Solana community. A lot of folks, they were indirectly or directly impacted by FTX. So want to take a second and acknowledge that. A lot of people, I think, are getting back on their feet, which is good. And I think this is going to end better for everyone than how it started. So I'm feeling pretty positive about things now.
Yeah, I think we've all been a bit distracted with everything unfolding, blow by blow on Twitter. And the cool thing is that the builders are here to stay. And I actually sense that in the Solana community, that this is a real trial by fire, and the core community is going to stick around. And so, yeah, it's good to have you on. And I know that you're embedded in the Solana community, but you're also kind of taking a new spin on it. You're taking Solana modular. So anyway, I think let's start out by just tell us a bit about your background. I know that previously you were in the dark side of finance over at Citadel. Like what brought you over to crypto?
Yeah, so I was working over at Citadel. I was doing commodities research, so specifically doing power and gas. And I was always interested in crypto. I bought my first Bitcoin in like 2015 or something. But around March of this year, I left. I was reading a bunch of crypto white papers, and I started building something in the Terra ecosystem. So I was building an EVM. It's a way to run Ethereum bytecode on Terra. And I thought that was interesting because I just saw how quickly Binance Smart Chain took off, given it was EVM compatible. And I saw all these other EVM compatible L1s really precipitously growing. And I saw Terra growing without that. So I thought it was a very natural idea to bring EVM compatibility to one of these Cosmos chains. Obviously, Terra depegged. And then you reached out, and I chatted with the Celestia team. I was already talking with Jacob Arluck before he had joined Celestia, and he had already sort of gotten me primed to like the Celestia thesis. You guys made a very strong argument that rollups were the path to scaling crypto. I read up on my own, came to the same conclusion, and hit the ground running and started talking with a lot of folks in the Solana community who were interested in the idea of having their own Solana VM rollup for many of the reasons mentioned. Just that they get to customize the rollup however they want. They get sovereignty. They can always leave the L1 if they want to. And those are the kinds of benefits that we want to bring to the Solana community.
Very cool. Well, started out in Terra ecosystem, and then it depegged. Now you're in the Solana ecosystem, and all this stuff is happening. you're 0 for 2. No, I'm just kidding. So you touched on it a little bit that, we reached out to you and we started talking to you about modular blockchains, and Jacob obviously was sharing sort of the modular viewpoint. But I'm curious if there was an aha moment for you, or like when did you really feel like you fell down the modular rabbit hole, and what was it that spoke to you?
I think it's after Terra's depeg, I saw a lot of the TVL flow out of a lot of the L1s. And then I realized that every time we spit up another L1, in order to secure it, you basically have to split the security and take some of that security from existing L1s, because there's only a finite amount of economic resources out there. So if you're like a proof of work chain, for example, you spin up another proof of work chain, some of those computers now have to secure this new chain. And at some point, and if that's the only way that we're going to scale, then at some point we're just weakening the security every single time. Whereas for rollups, it has the exact opposite effect, where you're building on top of the same decentralized base layer, you're increasing the economic activity, and that increases the fee, but then that also incentivizes more computers and more nodes to join this highly decentralized base layer. So that was the sell. And I think that's still the reason why I think that it's the most viable path toward economic scalability, or like economically sustainable scalability.
Yeah, I agree with you. You're touching on the point that, in a roll-up setup, everyone's sharing a common security layer. And rather than fragmenting that security with separate blockchains that then have to, spin up their own validator sets, have their own proof of stake token or what have you, you can all kind of share down your resources into one common layer. And it just it makes a lot more sense, and it's also lower overhead to launch a new chain. Absolutely, yeah. There's so many different aspects of it, but I'm so glad that we had those conversations and convinced you to sort of hop into the modular ecosystem. So now tell us a little bit more about Eclipse specifically. We know that it's Solana virtual machine rollups, but give us more color. Give us a little bit more of a overview of the project.
Yeah, so the way that I've been describing it lately is as Solana virtual machine rollups as a service. It's like you want to have your own chain. Maybe you're a Web2 company who wants to build a Web2 scale application. You're Disney and you want to let people stream movies and stream micro payments as they're watching it or something like that. So you want to have your own chain and you want to use the fastest VM out there, which right now is a Solana virtual machine. And you want to be future proof. Even if some L1 becomes outdated, you don't want to have to rebuild all of your code. You want to be able to swap that out very easily. So this is the motivation behind it. And the problems that we basically have to solve in order for that to work is we have to first factor out the Solana virtual machine and the Solana execution layer from this very monolithic repo. Second, we have to turn it into a rollup. So we have to set up this scaffolding for optimistic settlement. And the third thing is that we have to basically enable IBC messages to connect it to the Cosmos ecosystem, which has never been done before, but that's why we received a Solana Foundation grant. And that's how we initially funded that development.
Got it. So on the technical side, you're taking the Solana sort of virtual machine out of the Solana consensus, all the rest of the node software essentially. So you're isolating that piece. Then you're building this sort of optimistic roll-up capabilities as well as like a settlement layer. And then the last part is the IBC sort of for interoperability. So you're I guess, adapting IBC or making it compatible with the Solana VM.
Right. Yeah. Like if we wanted to build on Ethereum and that was the only L1 that we wanted to support, then we would have implemented the Solana optimistic rollup settlement on Ethereum as a smart contract. But the reality is that we're not that long the Ethereum donk sharding roadmap because it's so slow. And I feel like Celestia is already there. Like that's the reason why we like Celestia so much, because it's what Ethereum should be. And it's what they already should be working toward much more aggressively. And I think that it basically gives us the opportunity to launch a blockchain of the future now, rather than waiting for like Ethereum's roadmap to actually come to reality.
Mm-hmm. Yeah, I think, well, to Ethereum's credit, I think that they, are willing to adapt, right? And they were one of the first ecosystems to actually go all in modular, with the rollup centric roadmap. And over time, their sort of tech stack or their end game has become started to look more and more like Celestia's roadmap.
Agreed.
But, unfortunately, or fortunately for Celestia, we're starting from scratch, whereas they have sort of this monolithic L1 baggage essentially that they have to kind of build around. I think that they will get there, but it's just inevitably a much slower process, and there's so much more value at risk. So, yeah, I understand where you're coming from. So you talked a little bit about the different, Ethereum as a settlement layer versus other places. Tell me why, how do you see settlement playing out in the long term? As will there be one settlement layer to rule them all? Will there be one virtual machine that everyone settles down to, or is there going to be lots of different ones, and why?
Yeah, so I think the settlement layer to some degree has to accommodate the execution layer that you're running on top of it. So for the Solana virtual machine, if we wanted to use multiple layer ones, then we could have re-implemented settlement on every single layer one. But because we want to allow people to customize that, we have to break the settlement layer out. So similarly for other virtual machines, such as the EVM, I'd also expect people to build honest minority settlement layers for the EVM, which I think Astria is doing, or maybe Dimension, and any other, maybe Move, for example, might have its own honest minority settlement layer. Then we might also see settlement layers that exist on L1s, but then that also sort of makes the L1 less specialized, because now it's not only used just for data availability, but it also has to have settlement capabilities. So that's kind of what I see as the future of settlement. Maybe you'll have people doing settlement on Ethereum, and then you'll also have honest minority settlement layers. But I see very little reason to be doing, for example, settlement on chain on Solana. That seems like the worst of both worlds.
Yeah, that makes sense. And do you think that it makes sense to couple settlement with the data availability layer? Like, should settlement be enshrined, or should it be like it's a separate chain that builders can build?
Yeah, depends on the use case, right? I feel like if someone's willing to pay the fees to make it an Ethereum rollup with settlement on Ethereum, then they should go for it. But if you look at like Optimism right now, it's still not trivially cheap because Ethereum gas fees are still high. They have to do settlement on chain. If they did settlement elsewhere, then I mean, it'd still be pretty expensive because now they still have to store data somewhere. But in the case that if Ethereum actually builds out their donk sharding plan and it was just used for data storage, then that's like a much more affordable option. So I think it depends on how decentralized or like how much you care about the security of the but I guess it basically depends on what your threat model is.
Yeah. Well, the reason I ask is that we get a lot of flack from people about not having enshrined settlement on Celestia because in some ways, it makes it so there isn't like this easy pluggable option for rollup developers. So, it means that people have to.
Yeah, you should do settlement somewhere else now.
Yeah, but what people don't realize is that actually you can build a settlement layer on top of Celestia, and those are already happening. Eclipse is going to be one, Astria, Dimension. There's a bunch, and I think for Celestia, what we really care about is being credibly neutral. And I think in order for a data availability layer to be credibly neutral, it should not enshrine settlement because it's kind of, it's favoring one specific settlement layer, one specific type of settlement environment. And rather, we want to be as universal as possible and cater to as many different ecosystems as possible.
Agreed. Yeah, that's what people are sometimes confused by that because they'll ask, how is it possible that you're doing a Solana VM rollup that's storing blocks of data onto Polygon or something or onto Ethereum? Because those they don't use the SVM. But that's exactly the point because we factored out settlement, and settlement isn't tied to the data availability layer. All that DA is doing is just storing blocks, and that could be blocks of it from any virtual machine.
Yeah. So we covered settlement. I now want to shift to execution and, the different execution environments out there. Obviously, EVM was the first and the most widely adopted, probably has the best tooling, the most projects building on it. But where do you see the Solana VM growing in the next few years? And what do you think has contributed to its success? Because I would say the Solana VM is the second most widely adopted blockchain VM after the EVM.
Yeah, the SVM is solving a different problem, which is that the Solana virtual machine and specifically the C-level runtime is highly parallelized. So it's optimizing for just extremely high throughput. And as a result, it imposes more requirements on developers, such as the fact that you have to say what addresses you're going to read from or write to, because that's how it enables that parallelism. But I think that there's a lot of cool stuff going on, such as like Seahorse Lang lets you write Python programs, or you can write your Solana program in Python, and it'll actually convert it to a fully typed Rust program that can then be run on Solana. There's like a great fee market coming up. Soon, the Solana VM will support Move bytecode, and Neon's coming out in December, so it'll support EVM bytecode. So the Solana VM is like the Swiss Army knife of virtual machines. It can support all sorts of bytecodes. It's super parallelized, and that's why we picked it. When we were developing the rollup initially, we were like, should we just make our own bespoke fast VM? Should we just borrow Move? But these are like untested, and this is like a completely new territory. Whereas if we use the Solana virtual machine, then we benefit from all this tooling that already exists. So that was the thinking behind why we chose it.
That's pretty wild that you can run. I guess you were already kind of doing that, but that you can run Move or even EVM bytecode on the Solana VM. I guess that touches on your previous project, which was you were trying to build an EVM on top of CosmWasm on Terra. So
yeah,
I guess that you're pretty familiar with how those things work. But
the way it normally ends up working is like it'll be a fork of some repo, like Sputnik VM is an EVM implementation for Rust, and it's almost kind of like Geth, like Go Ethereum. It'll go through each line of bytecode and be like, oh, you want to add these two numbers? I'm going to add them now, and it just goes through line by line, and it's a smart contract written and deployed to the blockchain that you want to have like EVM capability for.
Yeah, the interesting thing is that this also connects to settlement in that, a settlement layer, it's easy for it to, for example, verify a fraud proof within an execution environment that it knows about. But if it doesn't natively know about that execution environment, then it has to verify that fraud proof within a smart contract that understands that execution. So I guess I hadn't thought of that before, but it's actually a very similar problem. So maybe even the Eclipse settlement layer can use some of this technology to, in the future, settle rollups that are not only Solana VM rollups.
Yeah, definitely. And I think it's a lot easier when you're building your own settlement layer because you can control the gas costs and stuff. Whereas if we were trying to do Solana VM settlement on Ethereum, then like maybe some of the elliptic curve operations or something are super expensive to settle on the Ethereum L1. Or maybe it's just like not even, it's just prohibitively expensive and it's not possible at all. Whereas by having our own settlement layer, then we don't have to worry about that. And we'll always be able to do the settlement. The question is just like, what is an honest minority with respect to? Like which L1 are we depending on for security? And that's sort of up to the user.
Got it. Well, we're getting pretty technical here. But one last thing on this sort of general thrust is, how do you think about the difference between sovereign rollups and rollups that actually aren't sovereign, that use a settlement layer? Where do you see the trade-offs there, and which one are you building for in the long term?
So like Eclipse rollups aren't sovereign from the Eclipse settlement layer. They're like governance rollups, whereas a sovereign rollup, like our settlement layer is sovereign, like in the sense that like the settlement layer doesn't necessarily rely on any particular L1, but yeah, I think that the thinking is like if you want to be able to truly replace all the parts of what your chain is building on, then obviously you need complete sovereignty. But I think most people don't want to be responsible for all of those parts, and that's what's nice about having this variety of options. It increases the design space, and people can say, "Oh, I'm okay with relying on Eclipse for settlement because I feel pretty confident they're going to do that correctly." And we'll give them the option where if they want to plug in their own consensus and become their own layer one, then they could. But by default, I don't think if people want to have that. I don't know if they need that level of sovereignty. Whereas being like a sovereign rollup, I think is a really good in between stage for someone who was like previously their own layer one. Then they become a sovereign rollup, so that's like a first step for them. And then maybe down the line they become just like a total rollup, and they're dependent on some other enshrined layer.
Yeah, to me, modularism is all about choice and flexibility. And, obviously Celestia has been beating the drum about sovereign rollups, but it's not because we think that sovereign rollups are better than non-sovereign rollups, or, that you have to build one way or the other. It's just that we think people should have the choice, and, other ecosystems like Ethereum, overemphasize that you have to use the settlement layer, right? But like we feel that it's important that people realize that rollups can be their own chains in and of themselves. They're not fully independent because they do borrow the security of an underlying L1, but they don't have to post their state updates somewhere. They should be able to, via their own social consensus, fork and upgrade and do these things if they want to. If they don't want to, they don't have to. It's totally optional. So yeah, that's it's cool that you guys are kind of like, you see the pros and cons. And I think most people may, if you're a casual developer, you might just want to, deploy onto a settlement layer. It actually makes your life a lot easier in a lot of ways. So there's no right and wrong.
Yep, agreed.
So let's go back to Eclipse a little bit more specifically. So you guys are going to build the settlement layer, and it is its own standalone chain with a set of validators, or is it going to be itself a rollup that has its own sovereign settlement?
Yeah, so the settlement layer is honest minority, so it is a rollup. Yeah, and it'll post those blocks of data for the settlement layer to Celestia.
Mm-hmm. And it's going to be an optimistic rollup with fraud proofs that are sent around on the peer-to-peer network.
Yep, that's right. Yeah.
Got it. And so
eventually we'll become a zero knowledge rollup, and we're developing that right now. We're actually leveraging the risk zero code, and we do this JIT compilation between Solana programs, which is typically BPF bytecode, and RISC-V bytecode. And then we use risk zero, which is able to run RISC-V bytecode and give a zero knowledge proof.
Yeah, I'm a real fan of Risk Zero. For the people listening who aren't familiar, Risk Zero is building a proving system for the RISC-V instruction set. So what that means in more like layman terms is that you can take code and then compile it down to RISC-V and then prove it. And that way you can build it makes it a lot easier to build ZK rollups because rather than using these new instruction sets like Cairo, RISC-V already has a ton of support. It might not be optimized, but it has the support there. And it's very easy. I think like there's already compilers, right, from let's say Rust or a lot of these like high level languages down into RISC-V. So that's really exciting. So you're starting optimistic.
Yeah.
You'll pivot towards ZK in the future when that's ready.
Yeah, and it might even just be an option that we give to people. It's like, you deployed an Eclipse rollup. Do you want to use optimistic settlement, zero knowledge, or do you want to just do like proof of authority? That's an option too. And it might make sense for a lot of these centralized entities who are moving into Web3. Maybe they just want to run all the nodes, but they also want to get the benefits of like transparency, and people can make sure that nothing was done in an invalid way. Maybe they do have like some sort of verifiable randomness still, but then they also want to collect all the sequencer fees themselves, or maybe they want to subsidize gas. They have some reason why they want to run the nodes themselves.
Mm-hmm. Yeah, one of the things that I find really interesting about modular blockchains is that, the earlier cycles, those of us who've been around since, 2017 and 18 wave, one of the really popular things was enterprise blockchain or like private blockchains. And obviously nothing really came of those things like Hyperledger and all those things for obvious reasons. And that's because, blockchains, I think that the real value proposition of them is that they're public and verifiable. But so if someone's running a private blockchain, it's like, well,
why not just use a server at that point?
Yeah, exactly.
A SQL server or something.
Just use a server, right? But the interesting thing is that what rollups do is I think they strike this middle ground where you can have, let's say I'm Circle, right, and I want to have like a USDC chain. It's probably bad for me from a regulatory perspective to launch my own blockchain and have my own proof of stake coin and whatever else. And this would be the same for lots of different enterprise entities. But I would also, if I launch on, let's say, Solana or Ethereum, I may not have the control and the customizability or even sovereignty that I might want. So you're kind of stuck between these two options. And the cool thing about a rollup is it's kind of like that Goldilocks like middle ground where you can have your own chain without actually having to, do all this kind of regulatory scary stuff. You're just paying fees to the data availability layer, and yet you have the customizability and sovereignty of your own chain. So I could see a lot more enterprises using rollups going forward because they just kind of unlock a new use case.
Yeah, enterprise rollups make a lot of sense, especially compared to enterprise L1s, which don't. And maybe that's what FTX should have looked like a centralized exchange where, because you still want to control stuff like making the blockchain permissioned. You don't want random people being able to on-ramp onto the exchange necessarily if they're a centralized exchange. But then you also get proof of reserves, and maybe they could have somehow incorporated proof of liabilities. We could have prevented the kind of fraud that occurred.
Yeah, absolutely. If everything was on chain, if it was a roll-up, it would have been transparent. There would have been safeguards, essentially. Like they wouldn't have been allowed to take your funds. It wouldn't have been custodial to begin with. So again, like I feel like I'm almost there, but I want to fully understand the sort of Eclipse stack. So we mentioned three things at the beginning. One was taking the Solana runtime out. The second one was the fraud proofs and settlement. And the last thing was IBC. We kind of talked about the fraud proofs and settlement. I'm curious, like, how challenging has it been to extract the Solana VM from the Solana node software?
Yeah, so it's pretty monolithic, but I think what Jump did recently with Fire Dancer is really interesting, and we haven't looked too carefully at it. just given that we've been working with the Solana core repo, but they basically turned the Solana client into this modular repo. But the thing is, now in order to run that, it's like 10 different binaries. You have to run all of them separately. So there's pros and cons to it, but it also means that you can take like a piece out of it and like use that separately. So yeah, what we basically want to take out the vote messages in particular. Because if you look at the Solana blocks, if for every validator they have to put this additional transaction in, and that's counted toward the Solana transactions per second. So if you look at like popular public measurements, it'll say Solana's TPS is like 3,000 TPS or something like that. But actually, like 3/4 of that is votes. So the true TPS is closer to like 700, 800. Whereas for Eclipse, we don't have those vote messages. So we're actually able to get more throughput out of the Solana VM.
Wow. Yeah, I think a lot of people don't really. There's a lot of fun. It goes both ways. People are always like, "Look how high the TPS is," and then all the ETH max is like, "Oh, well, all of its votes." But then it's like, well, even if it is most of its votes, it's still pretty high. But yeah, I find it interesting that choice was made to have the votes like as actual like transactions. But yeah, you touched on the fact that I didn't realize that the FireDancer was making the Solana stack modular. It's cool because like we're seeing this across all the different ecosystems. Like obviously Cosmos was the first, and again for the audience, like there's an important distinction between modular software stacks and actual modular protocols. So like when we say modular blockchain, what we mean is actually a protocol that itself is modular, meaning it just does one function like data availability or does execution. But there's also this other side which originated with Cosmos, which is modular software, where the way that they built their software, like they still build monolithic protocols, but the software inside the protocol is modular. So you have the piece of code, the library, or the piece of code that runs consensus. Then you have the piece of code that's actually doing the execution, like the state machine and all that. And so Cosmos kind of started this with Cosmos SDK and Tendermint, and then Ethereum started going this way more recently with they have like the execution client, and then they have the actual like ETH2 like proof of stake client. And now I didn't realize that Solana's doing the same thing. And there's just so many benefits. It makes sense. Like modularize everything, including the software, is kind of my perspective, and it probably is going to make your guys' life a lot easier, I imagine.
Yeah, you can do things like swap out the consensus or throw it away altogether.
Very cool. And then now to finish up sort of the Eclipse stack, tell me a bit about the IBC side of things. Like, what are the challenges there, and what does development look like?
Yeah, so this is the first ever IBC implementation for rollups. And then it's also an IBC implementation for the Solana state. So for rollups, especially for optimistic rollups, usually there's a challenge period. So if you go and send IBC messages out of your optimistic rollup, that can pose an issue if your optimistic rollup is rolled back. Because for the next week or however long the challenge period is, that's always a possibility. So you actually need those IBC messages to be either subject to a challenge period where you could pass a fraud proof, or you just only send the IBC message when finality has already occurred. So that's the challenge with IBC. It also requires just there's like different elliptic curves that are used for Solana. So a lot of IBC I don't think any IBC relayers support the elliptic curves that are used. So that's the kind of work that we have to do. We push a lot of that upstream. So that's the IBC work. And then you also have to implement just like a regular bridge. So like a non-IBC bridge, maybe one that uses full nodes. And the reason for that is that then you can get fast finality bridging out of the Eclipse network, because otherwise you'd always have to wait that challenge period.
When you say like full node bridges, what do you mean? Do you mean something like
it should be like something that's running it's running the Eclipse client, and it's just following all of the Eclipse blocks, and it's actually it's aware of like what the fork choice rule is, and it basically, if you want to bridge your money out, it's like, all right, nothing's going to get rolled back up until this point, so we can go ahead and just do it.
Got it. But that's not running on chain, right? So that would be like an intermediate service like Axelar, or
yeah.
Okay, got it. Yeah, and didn't I think, if I recall correctly, the Solana Foundation gave you guys a grant to build support, like IBC support for Solana, essentially.
Yep, that's right. Yeah, that's what our grant is for, to basically build IBC messages for the Solana VM.
That's pretty cool. I like it's very cool to me that the Solana ecosystem is supporting you guys and the work that you're doing, because I think it's going to benefit them, in the long term for sure. So
Agreed. Yeah, Anatoly is the nicest guy. Also personally angel invested, and the thinking is that if there's going to be a bunch of rollups and chains out there, they'd prefer that it's the SVM rather than some competing execution layer like the EVM. And it helps everyone because we might make improvements to the Solana virtual machine as well. Like we're gonna possibly work with Skip and introduce the concept of blocks back into Solana. And maybe that's not ideal for the Solana L1, but the reason why you might want it in a rollup is because now you can do an MEV auction.
mm-hmm.
So that's like, it's just giving people more options on how to use the Solana VM.
Yeah. Well, Anatoly and the whole Solana team, we have a lot of respect for them, and I love that they're very positive sum, and
Yeah.
For Celestia, like our ethos is modularism, not maximalism, right? It's like it's not about competing and who's going to be the chain or the ecosystem to rule them all. It's like, hey, this is a positive sum game. We are each building different components and contributing to this like larger, this huge, tech stack. And if we build it in the right way, it's going to be possible for everyone to sort of like benefit together, and builders will win as well because they can mix and match everything. And so, yeah, I'm really stoked that the Solana ecosystem is backing you guys. For people who haven't heard of Skip, another really exciting project coming out of the Cosmos ecosystem that are taking a new approach to MEV, like a more modular approach to MEV. So I'm excited to hear that you're working with them as well. So we got the Eclipse stack, those three different components. Now I'm curious, like, where does the data availability layer come in? Where does, for example, Eclipse plug into Celestia? How does that work?
Yeah, so the execution layer for Eclipse, so the Solana VM produces a block, and that's stored on some data availability layer. Or alternately, you could pass that to the settlement layer. The settlement layer does whatever work it needs to do, and the settlement layer stores both its blocks and the execution layer block onto Celestia or whatever DA layer you want to use. So like we've chatted with other DA layers like Polygon, Abil, and EigenLayer, but we're excited to be starting with Celestia, and we'll continue supporting it because like Celestia is also like the whole motivation why we made this like blockchain modular, and I think it's going to be first to market, so that helps too.
Mm-hmm. And how do you see? So just to explain again, so you have the Eclipse settlement layer, which is itself a rollup on Celestia or another data availability layer, and then you have the other sort of Eclipse instances, which are rollups that are settling to that layer, and they're all kind of posting their data down, or they might post it to the settlement layer and then down, depending on sort of their preference.
Yep.
And will there be a separate? So let's say you'll first launch on Celestia, then let's say Avail is live later. Will you launch a separate settlement layer on top of Avail, or will there be some way to unify these ecosystems and have one single settlement layer across them?
Yeah, this single settlement layer, right now the way it's being designed is this one settlement layer will be able to post to different data availability layers.
Got it. And so will it post to all of them simultaneously, or will like users choose?
I think you would just pick one. Yeah, so that's like the thinking. If you deploy a rollup, then you get to pick which DA layer do you want to use, depending on maybe some DA layers are more decentralized or something, and maybe they're more expensive, whereas other ones might be totally centralized and super cheap. So they get to pick that part, and we leave it up to them.
What That makes sense. And how do you guys see the sort of evolving ecosystem of data availability layers? Like, what do you think is most important for a data availability layer to provide? And like, why would a developer or a user or an ecosystem like Eclipse choose a specific one over the other?
Yeah, well, I think table stakes is just the sophistication of the data availability proof. So some chains just have better data availability sampling than others. Or maybe like the worst case is if you just have to store the full block, and then it's not really doing data availability, but it's just doing data storage. And that's how we're implementing it for the Solana L1 right now. We just have to store the full block there, and there's no sort of clever sampling that's going on. And that's also a very expensive solution. But maybe some user wants to use Solana because maybe that's where they're coming from. Maybe they like Solana consensus and they're willing to pay the price for that. And alternately, they might go like even more extreme and store it on Ethereum or something where the fees are even higher. But I think ultimately people are going to be thinking about what's their cost preference and their cost sensitivity, and they're going to be thinking about what are the other benefits that a specific data availability layer confers in terms of like how decentralized is it, and like whatever other properties. Maybe they might prefer like a KZG commitment if they want to have some sort of like zero knowledge data availability proof. Maybe there's some more sophisticated users might have preferences about that.
Mm-hmm. Yeah, I think what you were touching on there is the overhead, right, of a data availability layer. Because so if I'm a rollup and I'm posting my data to a specific data availability layer, then all the clients of my rollup also have to check that the data is available. So if you're using a monolithic blockchain like Solana, or even right now the EVM that does not have data availability sampling, you have to actually just download all that data. You have to go and like retrieve all of it, which is a lot more overhead. And in a blockchain like Celestia, it's just sampling. So it's a very, very light process, and very, very low overhead. So I think that's definitely a big one. And also like the actual security of the scheme as well, how secure is their sampling scheme? I think there's going to be a range of trade-offs there. And then, yeah, as you said, the KZG versus optimistic. From our perspective, at least from what we've seen in the benchmarks of KZG commitments, they're just very expensive and slow to compute. So it's it doesn't seem practical at this stage, but it might be. And there's actually even a possibility that there's going to be other ways of having a sort of validity, like a non-optimistic encoding scheme, but only Mustafa could explain that to you. But yeah, that's cool to hear your guys' perspective, on the different trade-offs of data availability layers. It's going to be really exciting to see as more of them come online how they measure up to each other. And I think cost obviously is going to be a big one. How do you guys think about costs in the data availability landscape? Like, is that really one of the main like points of the trade-off curve for you guys? Like, oh, this one's it's too expensive, or is it going to be like, as long as it's below a certain threshold, that's fine, we'll use it?
Yeah, like similar to you guys, we try to maintain credible neutrality. So if someone's building an Eclipse chain, we don't want to like push our preference on them. Me personally, like that's definitely something I was thinking about as we were building this initial version of Eclipse out, because I was initially going to deploy it to Ethereum, and the cost was just so prohibitively expensive that I was like, this is just never going to work, and we need to find some other solution or just scrap the idea altogether, unless there is some data availability layer that exists, and that's why Celestia was a perfect solution. Uh, but yeah, I think for most people, I think it's something more like there's a threshold where people think this is effectively zero. Like if they're using the Solana blockchain, for example, the gas cost in general is so low that people don't even think about it. Whereas for Ethereum, people 100% time the gas. Like they'll be waiting there. They're like, oh, I should wait 30 seconds because that's the site suggested time or whatever. So that's it's like a 0-1 thing on whether people are thinking about gas at all or whether they're not thinking about it. And then there's like the other binary decision, which is just, is this so egregiously expensive that it's just off the map altogether?
Mm-hmm. Yeah, I think the real benefit for the ecosystem of data availability layers is that it's going to make block space so abundant and so cheap. And hopefully we can go back to a world where users and developers it's not something they think about. It's not like they're like, oh shit, I really got to optimize this gas, or oh, like I want to wait. Oh, today gas is too expensive, so I'm just not gonna, mint my NFTs or what have you. So I'm excited for that to happen. And the last question on data availability layers is, what do you think about like the ecosystem on top of a data availability layer? Do you think that that's important, like the network effects of, let's say, the other rollups? Because as you know, one of the benefits of a modular blockchain stack is that rollups that are built on a common data availability layer have trust minimized bridging, meaning that they can bridge in a fully secure way. So there is sort of a network effect around that property Do you think that that's going to be an important thing, or do you think, developers are going to be like, you know, trusted bridging is
Yeah, I
fine,
think
or
that the
like,
network effects accrue. Yeah, I think they accrue more to the settlement layer. Because if
mm,
you're like bridging money between, like, yeah, you definitely, if you're sharing a data availability layer, then obviously, like, you only have to rely on this one assumption, which is that L1 is not going to be like compromised or something. But also, it's like you can get fast finality bridging between optimistic rollups that exist on the same settlement layer. Whereas if they're on different settlement layers, uh, I guess you'd run the risk that both of these chains get blown back or something. So, yeah, they're effectively like sharing settlement layers in some way. So yeah, I guess that's what I think that like the network effects for rollups are a little bit weaker than on a monolithic L1, just because when
mm-hmm.
all the smart contracts are deployed together, then of course you get atomic composability. But yeah, there's definitely still some serious network effects in bridging.
Yeah, it's going to be exciting, and I love having debates on Twitter with people about, where will the network effects accrue, because it's still
Uh,
anyone's guess. Uh, so, zooming out to just the modular blockchain ecosystem in general, what are you most excited about, uh, and where do you see the space evolving as a whole?
Yeah, I think I'm really excited about those sorts of institutional roll-ups that we were talking about before, where like the Disneys of the world or Spotify's or something might have their own roll-up. Or I think games having their own roll-ups is really interesting. Mythical Games is building their own L1 right now, which probably doesn't make that much sense in the context of what we're discussing, which is that they just want their own execution layer really, and they don't want to have to worry about like running the infrastructure for an entire L1. So I think we're going to start seeing more of that. I think gaming is a really great application because oftentimes games could use their own chain for a variety of reasons. Maybe they want to adjust block times, or maybe they want to mint a million NFTs. I think that's one cool wave. And another one is token incentivized physical infrastructure. So Helium drops, I think, like a million NFTs every week, some crazy number. And there's not really a great chain that can support that volume of NFT drops. Even Solana, like NFT drops are famously what causes Solana to throw up. So having like having infrastructure that's like designed for NFT mints, it probably shouldn't be its own L1 because like now rollup tech is at the point where we can actually use it. So I'm excited to see like unique solutions to the kinds of problems that have sort of hampered the mass adoption and scalability of applications on layer ones. So yeah, those are the two things I'm keeping an eye out for. And I think it's got to get to a point where it's as easy as deploying a smart contract, or even simpler than that. Even smart contracts are almost too difficult because if I want to deploy like a website to AWS, they have all these like you could like spin up your own instance and do all that stuff, but they also have extremely simple ways to just scaffold it instantly, just deploy it like straight with your CLI. So we need stuff like that. I think that's the next wave.
Mm. Well, you took the words right out of my mouth, when that's kind of been our vision, and I'm glad that you share it, of making it as easy to deploy a new blockchain as it is to deploy a smart contract. And actually, even like you said, further, it should be, like AWS, it should be like cloud for Web 2, where, it's just a few clicks and then boom, you have your server, your website, your web app, whatever, live and ready to go. And it can scale up and down, you can shut it off, all those things. That level of flexibility is where we should be shooting for. And I think
I agree. People aren't thinking like nearly big enough in terms of how usable crypto needs to be in order to have mass adoption. Like these tiny things like waiting challenge periods or waiting for gas, like that people are like, oh, it's like not that big of a deal. But that's like leagues away from where it has to be in order for like my mom to be able to use crypto. She's not going to wait for gas prices. She shouldn't even know what that means.
yeah, absolutely. Yeah, I think we will have one when, people aren't really aware that they're using a blockchain necessarily. Like it just works. Yeah, that's amazing. So to wrap things up, I want to ask you, where is Eclipse now in the development cycle? When, what are the upcoming things on your roadmap? When can people start trying stuff out and using things?
Yeah, so we're excited to launch our testnet end of January, beginning of February next year, so 2023. So Q1 2023, we'll have three testnet chains. One's for DeFi, one is for consumer gaming, NFT stuff, and the last is for token incentivized physical infrastructure. And they're going to be able to pass IBC messages between each other. Sounds like we're probably going to enable testnet IBC messages, possibly with OKC or some other chain, just to kind of show that we're able to pass IBC messages outside of the Eclipse network. We'll support Celestia as a DA layer, possibly others such as Polygon Avail or EigenLayer, depending on if their testnets are ready to accommodate us. But at a minimum, we'll support Celestia. And yeah, that we're giving early access to a handful of protocols. We're keeping it to 30 protocols for early access, but there's like hundreds of protocols that have signed up, and we'll let them just deploy on their own. But we're going to actually handhold some subset of these protocols who are either especially big protocols that are moving to Eclipse, or maybe they just are a unique use case. They're just getting started, such as a lot of these token incentivized physical infrastructure projects are just they're early enough where we're even connecting them with venture partners right now, and we're helping them with their architecture. So we might take a more hands-on approach for some of those.
Wow. So you already have your testnet coming up. You have people already lined up, ready to go. Lots of first use cases. That's amazing. And where do you see Eclipse? When do you plan to launch mainnet? And then, like, what do you see for the first, let's say, year or two of the project from there on out?
Yeah, so mainnet will be end of Q2 of next year. So we're going to align with us. Obviously, we're like limited by Celestia's mainnet launch, so we'll sort of time it with you guys. And yeah, after that, I think the next step is getting these like big Web2 enterprises to start deploying Eclipse chains professionally. And then it'll be self-service. We'll enable settlement. So initially for the testnet, we're going to run all of the nodes ourselves, similar to Optimism's launch where they run the node, they don't enable settlement, so they don't enable fault proofs. But we'll enable that stuff later.
Got it. Yeah. Well, Celestia mainnet launch Q2 2023. Stoked that you guys will be there with us along for the ride. So if people want to, is there any last message you want to share with the audience, and where can people find out more about Eclipse?
Yeah. So one thing is we're going to be launching our brand soon. So you can sign up for our testnet on our website. You can put your email in. We'll send you details there. The second is to follow us on Twitter. It's Eclipse FND, Eclipse Foundation. That's our handle on Twitter. You can follow me personally, Neel Somani, and we'll be posting about all of the updates for Eclipse.
Cool. Well, Neel, I'm a big fan of Eclipse and what you guys are doing. It's been a pleasure to have you guys on Celestia Spotlights. You guys are the first project, which is cool. And thank you so much for sharing all this information.
Great. Thank you, Nick.
All right. Take care.